Hello, and a really big and warm welcome to you to this presentation from the Urban Penguin. My name is Andrew Mallett, and this presentation we're going to run through and start a series on Python scripting. Now, probably one of the best ways that we can learn anything is by making a game out of it, gamifying it as it's often called. We're going to look at creating ourselves a very simple game to begin with. It's just the heads and tails. So we'll look at how we can toss our virtual coin. So at the start of our game, we can decide who gets the kickoff. So if you want to start your journey learning Python, then let's go through and take a look at how we can create this game, heads or tails.
The roads have emptied. Only us left. Kids sleeping in the back. Cat's eyes shine bright. White lines roll by. The rhythm of the streetlights. Radio hums quietly. Rain starts. Hypnotic wipers. Pull in.
Remember, we're helping you learn Linux.
So hello and welcome. We're going to dive out to my Ubuntu 20.04 system, and we're going to be taking a look at working on a Python script. And one of the best ways to start learning Python is to make it a little bit of fun. So that's what we're really going to try and do by creating ourselves a little simple heads and tails game that you can then get through and fascinated with at least for 5 minutes or so. Now, we could create our code at the command line just using Nano or using Vim, whatever your favorite text editor is. But we can also use, if we have a graphical environment, we could use Pycharm. We could even have Pycharm on our client machine connecting over SSH to our remote system. So I've got Pycharm, the community edition, the free edition, up and running on my Ubuntu system, and it is part of the standard snap repositories that we get with Ubuntu. So it's easily installed. Working in my newly created Pycharm project, I can right-click on the project folder. Moving across to new, I'm going to be able to create myself a new Python file. Once I click on this, I can make sure the top option is selected and just add in the name of the file. So I'm going to add in a file called coin. I just write the word coin. I don't need to put py. It adds the py extension automatically for me. I can then go through and create myself a variable, but this variable needs to store both the value of heads and tails. So we have collections, and the most commonly used collection is a list. A list is designated with square brackets, and then we can have a comma-separated list of values. So I want some string values, and I'm going to obviously have the values of heads and tails. Now, I'm starting off with a list because it's the most commonly used, but it isn't going to serve our purpose too well. When I go through and put the order of heads and tails, a list maintains the order that it was created or appending values to. So the list is always going to be the same. We can show this by printing the contents of the list. And the easiest way is just to print the complete contents. So if I go to look at print and then my list name sides, hit the run button, and you can see then I'm getting a heads and tails. Every time I execute this, I'm getting a heads and tails. It's not so much good for a coin toss unless I'm the one picking heads. So what we need to do is create a different type of list. We have collections. List is one type of collection, but another type of collection is something called a set. Sets are defined with brace brackets. And one of the big features of a set is that they are unordered. So every time the code executes, the set is going to be created in a random order. So we've got our heads and tails here. The first element would either be heads or tails. It's not going to be stuck at heads. The other nice thing about a Python set is it doesn't allow duplicates. So if I'm collecting information from log files, we have multiple entries, they're only going to be stored once. As we start to execute our code now, we can see that we're alternating between heads and tails. We might get tails showing a couple of times or heads showing a couple of times. But if we ran this a few times, we'd expect it to be roughly 50% of heads and 50% of tails, because kind of that's what we would expect, isn't it? Same way as a normal coin toss. So this is quite good. It's working really the way that we want. But we don't want to display the complete set. The problem that we have is that the set is displaying. We just want heads or tails. Now, the bad thing about a set is that we are unable to access the values by any index number because they are created randomly. So what we do to overcome this, we can then populate our result variable, and it's going to be equal, it's assigned the value of a conversion. We are going to convert our sides set to a list. And that's what the list function is doing here. Now we need to open up our parentheses to specify what we want to convert. And of course, we are converting sides. Now, I know we were saying a list is ordered, a set is unordered. We created the set that generates our results, being heads or tails, and then we can go through and translate our set to a list. But being a list now, we can just pull out the first element. Being a zero-based indexing system, then our first element is actually index 0. You'll get used to that with computers, so don't worry if you haven't come across that before. The first element is going to be 0. Now as we print the result is a scalar or single variable, and it then just has heads or tails, and you can see now that it's really alternating between heads or tails. There you go, we got tails twice. But again, it's going to be randomly generated through the creation of our set. A set is unordered. We can pull out the result that we want. But we're going to set ourselves another scalar variable now that is going to have our user selection. So I'm going to call it user, and I'm going to assign the user variable the output of our input function. And in the input function, we prompt our user, dear user, what would you like to choose, heads or tails? Typically, I would have a space before I close my quotes, just to separate the prompt from the user entry so it reads better. For safety, we're going to convert the user input to lowercase, because that's what our original values are stored as, lowercase heads and lowercase tails. So we can convert our input and store it in the user variable. So we're starting to cook on gas now. We've got our result, and the user can choose between heads or tails. So we've got to compare our result with the user selection, and we do that with our if comparator. So if user is equal to, so we use the double equal sign now when we're testing equality, if the user selection is equal to the results, we put a colon at the end to designate we're going into a block. So if this evaluates as true, we then run the indented code that follows the colon. And that could be a single line as we're going to put in, or it could be multiple lines. The standard indent level is 4 spaces, but so long as it's consistent, it will work. The IDE here that we're using is using 4 spaces. So I can then print out the happy result, you've won. And we can even show what the selection was. So the coin showed, and we can include the variable if we put it in brace brackets. So we can go through and put result in brace brackets, but if we're going to display it in this manner, we must use format printing. So going back to our opening parentheses, and just inside the opening parentheses, but before the quote, we can put the letter F. And we can see now that we look at result, the color of those brace brackets have changed to orangey color. So we can see the syntax highlighting is working well for us. We only have one other condition to consider. So this is our else block. This is then lined up with our if, and then we indent for all of the code that should execute if else is then resolved to run. And we're, of course, going to say you lost, and again display the results. We don't need to print our main result now. And as we go through and execute our code, we can see now that we're being prompted to choose between heads and tails. This is now starting getting exciting. So we put in heads and look at that, we've lost. Well, let's try it again. I'm going to stick with heads, and let's go through and take a look. And look at this, we've won. So again, we can see then that it's working reasonably well, or as expected. But we can make this just a little bit more user-friendly. And of course, the best way to do that is to add a little bit of color. So if I use some variables, we might have red as a variable for our failure. And we put in here something reasonably ugly, but our color code. So \033 open square brackets 31M. And for green, it's very similar. So we're putting in our ASCII escape sequence, which is the \033, and then the color code that we want to use. And then that's going to be our square brackets and 32M, where we're then using it for green. Now, whenever we change the formatting of our text, we must reset it, otherwise it will stay the same color. And our reset is going to be then \033 open square brackets and 0M. Now, there are other colors that we could use, but this is all we really need. But consider putting these in a separate Python file and importing that Python module to pick up these variables. But for ease, we're going to keep the variables in the same file. We just need to set the color. So we're going to say if we won, we can be green. So we can just put the variable green. And don't forget to reset at the end. So we can then go through and put our reset. And then go through for our failure. We can add in the color red. Remember, our variables are going inside of our brace brackets. And then still within our quoted string, but just at the end, we can put our reset value. Now, with that done, we've got to our final iteration of our project, at least for the moment. Let's go through and execute it. Heads or tails. So we can go through and put tails. And you can see, look at this. Green shows that we won. So let's go through and try it again. And we'll stick with tails. Oh, look at this. We are on a winning streak. Well, okay, let's try it again. So game number 3, and we've won game number 3. 3 in a row. Are we going to be able to make it 4? Let's stick with tails. 4 in a row. Let's hope we haven't broken this. Shall I gamble everything on this? And execute for... Oh, I should have taken my winnings before. But we can see now that we've got our green and red output, and it's just becoming that little bit more friendly for us. Now, I know this is a simple example, but we've looked at our Python collections, and we've seen lists and sets. They both allow multiple values. A list is ordered, so as items are added to the list, the order is maintained. They can also store duplicates. A set is unordered, so we don't have any fixed order in which the ways the values are going to be shown, and it doesn't allow duplicates. We've seen how we can grab user input, and we've seen how we can evaluate to see whether or not we've won using our if statement. So hopefully you found this both entertaining and useful. If you did like it, then hit the like button and don't forget to subscribe.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.